Hello everyone and welcome back to my channel. Good to see you again. So this is our third session to learning AC and DC charging system. So as discussed in the previous videos, we completed the course introduction and the comprehension overview and talk about the key topics what you can expect to learn throughout the course. Okay, so let's get started. AC versus DC charging, how the electrical vehicle actually charge. So welcome back this course. So in this video we are answering a question that trip up a lot of people the first time they look at an EV charger. Why do some charger take 20 minutes of time and other take 8 hours? So this kind of question usually come into the mind, right? So we will see that what is the reason behind this. So this is our main topic for today. I will try to clear. I will try to answer this question. Okay. If you go on to if you're going to automotive engineer, power system, or the infrastructure planning, as the AC versus DC questions show up constantly. Okay. So in component sizing, in a cost estimate, in a grid impact studies, so pretty much you will know about this. So permitting discussion and the most of the time you will see all these questions. So a utility engineer evaluating the grid capacity for a new charging hub that need to know whether they are planning for a handful of 7 kilowatt of AC load or a single 350 kilowatt of DC load, because those have completely different implications and configured for the transfer the sizing and the demand charge. So this is not just a vocabulary, it's the first discussion point almost every EV in infrastructure project you will every touch. Okay, so going ahead, let's start with the fundamental architecture. As we know, every electrical vehicle has a high voltage battery pack, and that battery pack only accept direct current. Okay, in short, in DC, that's not a negotiable point, right? So battery always and only store charge as a DC current. Keep in mind. This is a very important point. So the question come in our mind, where does the conversion from AC to DC happen? So that single question is the entire difference between AC and DC charging. So basically what happened in AC charging? In AC charging, uh, we will try to find the answer of this question. Okay. So in AC charging, the electricity come from the grid. Okay. You can see in this PPT, um, you by seeing this picture, you will able to understand. In the system, you can see in the PPT, you can see in first box, the left one. This is the grid icons, the picture, right? So alternating current voltage oscillating between positive and negative 50 to 60 times in a second. Okay. So This is the alternating current that AC power flow through the charging cable into the car that only then get converted to the DC by a component inside the vehicle called onboard charger. Okay. So going ahead, so in AC charging, the charging station you plug into is not really a charger at all in the strict sense. It is always closer to the smart safety monitoring extension code. So this is the real conversion work is happen inside the car. Okay. Now in the other hand, the other side DC charging. So conversion happen outside the vehicle. You always see in this PPT, uh, if you're able to see here, you can see here one big box is there that is doing offboard conversion, right? It is always big in size compared to the AC charging station. When you see on the station, so in size comparison, compare the AC charging station is less size and the DC have a bigger size. Okay, because all conversion is happening in offboard conversion outside the vehicle. So all inverter or all instrument that is uh, that we are using, I mean they are using to converting the AC to DC. So all components are installed outside the vehicle, I mean off-board conversion in the station itself. So as I told, like the charging station take AC from the grid, run in through the large power electronics, like for example, is rectifiers. It could be rectifiers and the converters. Okay, I think one picture should be there. Yeah, this one. So you can see here the inverter is always required, that is converting our AC source to DC source. Okay. So that's why you will see DC station are physically much bigger than the AC station in size, as I told you earlier. Okay. They are carrying, what is the reason? They are carrying the power conversion hardware itself. Okay, as I told, all inverter and all component are installed inside the outer box, I mean outer station, out of the vehicle. Okay. Now going forward, that's why you will see DC station are physically bigger than the AC station in size. Be why? Because they are carrying the power conversion and the hardware inside itself. Okay. In other hand, in AC case, the size of charging station is very small. I mean, not a small compared to the DC charging is small. Okay. So it's squeezed into the car. It's okay. So this is always why DC charging is so much faster. So the one board charges car is limited in size and the weight. That why you can't put enormous power converter inside the vehicle without adding a cost and mass. So a station DC charging has no such a constraint. It can house conversion equipment rated or uh, rated of for 100 of kilowatt, which is why DC fast charging can push 50 kilowatt all the way up to 30 300 or 350 kilowatt up to. Okay. So while an AC charging typically site between about 2 to 22 kilowatt. So keeping this point in mind, this is the very important, like DC fast charging capability of 50 kilowatt to 350 kilowatt, while other hand for the AC it's very less, 2 kilowatt to 22 kilowatt roughly. Okay. Now going further, so I will try to explain you in very detail here with this architecture. So look at this picture. So this slide show you the two main way an electrical car get charged. On the left side you can see you have a AC charging. So on and the right side you have the DC charging for the same car, same battery, but two very different path for the power to travel. Let's walk through both side by side in detail. So let's you can see the left side. AC charging is coming, right. That is the AC charging part, the left one. So you can see here in PT diagram the left portion, all this portion. Okay. So you can see here in PPT diagram power being or start at the grid, right. This is coming from the grid. So from the grid it goes into the box called AC wall box. Just you can see after this grid one box is there, AC wall box, correct. So this is the charging station you did see on a wall at a home or in the parking. The lots is common, you can see a very common you will see in your uh, area. So look at the wire coming out the wall box, right. There is two wire, the right side, right. You can see here, not two wire, sorry, the three wire. Okay, before that let's talk about this that 4 wire that is coming out from here. So there are four of them you can see four wire is coming out, and each one has a particular job here. What they are doing here? So you can see here the orange wire, right? The orange wire. So, so the orange wire is a pure copper carrying the actual power. The blue wire is the electrical blue, that one, the blue wire, also part of the power path. Okay. So green wire is a protective earth, and that one is just for safety purpose. In case something going wrong, it is for the protection only. And then there is one more wire level live, which is the main power feed going into the car. Okay. So all of these wire go into the car. You can see here the vehicle inlet is directly going. So through the vehicle inlet, you can see 5 pin here. The vehicle inlet, if you are able to see here, 5 pin is there, right? Line 1, line 2, neutral, then control pilot, the proxy pilot, and power earthing. So P is here protective earth, as I told, say is used for the safety, same safety wire we just talked about. And then two more important pins, control pilot and proximity pilot, CP and PP. So here CP stands for the control pilot and the PP stand for the proximity pilot. So these two does not carry power, keep in mind. They carry information only. They are for the communication purpose. So they help to communicate between your vehicle and the charging station. This wiring has no electricity, right? Correct. So this control pilot and proximity pilot only used for the communication between your vehicle and charger station. They don't carry any power. So they let the car and the charging station talk to each other. They help to stabilize the communication between them. So the car knows its safety connected and knows how much power it allowed to draw. Okay. Now here is the most important part of this whole diagram. Look at the box inside the car. Here you can see onboard charge, OBC, that is for the AC charging is always placed inside the car. Okay. So it called the onboard charger. This is our here the make possible to charge our vehicle by using the AC source or OBC for short. So this box is doing the real work here. The power coming in from the wall, I mean from the grid in our case. As I told, AC is coming from the grid to your AC wall, right? But the battery can only store the DC, as I told you, keep in mind. This is a very important point. So this box sitting inside the car convert AC into DC. So this is the real hero here, actually you can say. So you can see it on screen. AC goes in one side and DC come out from the other side, right. AC is all this wire is that is coming from the AC wall box and going the onboard, and DC is coming out here and going to the battery, that's charging our battery. Okay. At the lower voltage, ready for the battery. Okay. So this is the key idea to remember. In AC charging, the conversion from AC to DC happen inside the vehicle, and that has the consequence. This onboard charge has the size limit and the weight limit because it's sitting inside the car, so it can only convert uh, not much power, it's not much fast. That's why AC charging is slower. That is the main reason. The bottom neck is this little box right here inside the vehicle. So, but there a benefit too. We can't say there is only the disadvantage of this, because the car is doing hard work here. The charging station outside can stay simple and cheap, right. So, that is why you see AC charger everywhere, at home, at work, on the street, everywhere. Reason, they don't need much infrastructure at all, and that minimize the cost. Okay. And finally, the converter DC power follow into the battery pack. So, right here at the bottom, that's the fully journey on the AC side. Grid to how is the full journey? Grid to wall box, then vehicle inlet, okay, onboard charger. You can see in the next slide. Okay, vehicle inlet, onboard charger, and finally then battery. This path you can follow, right. Grid to AC wall box, vehicle inlet, onboard charging, then finally in our battery. Now let's flip over the right side. Look at the right portion, that is the DC charging architecture. So this is the DC charging, and you can see the station itself look much bigger, right. Here you can see, and more complex compared to the AC charging. That's because the DC fast charging is doing the heavy lifting this time. So now our hero is our DC charging box that is placed outside the vehicle, not the car. So in this case, power come from the grid into the large unit itself. Directly from the grid is come directly to the power station, DC power charge station. And inside the unit you can see the conversion electronics already built in. The AC to DC conversion happen right here inside this box. Okay. In the station, before the power ever reach the car, all conversion is happen inside this box only. Going further, now look at the vehicle inlet on this slide here. Instead of line 1, line 2 for AC power, you now see DC plus and DC minus, right. In AC case, you can see here line 1, line 2 in vehicle inlet. That is the difference. You can see here for the DC vehicle inlet. I mean, in both, in a car, you can found both of pin inlet, sorry, AC type or DC type. So both inlet is exist over there in the car. Okay. So going further, let's tell you straight away, this plug is only for the direct current. Okay. So safety pin protective earth is still here, as similar to the AC charging vehicle inlet, and the two communication pin, control pilot and the proxy pilot is also you can see here, are still here to both communication pin are present, doing their same job as similar as the AC vehicle inlet. Okay. So they are doing same job as before for the communication. They make sure before transferring the current and voltage, they stabilize the communication between vehicle and your power station, not a power station, sorry, your charging station. Okay. Confirming the connection and the magnifying how much current is allowed to flow. So that they are agreeing both your AC and charging station and the vehicle. Then after that is power is going to be transferred. And here is the big difference. Look at the onboard charge box on this side. Here you can say this part, this is the bypass. I try to present you so you can easily identify the difference. Okay. So this is the big difference, because the power arriving from the station is already DC and the car does not need to be converted anything anymore, right. The power just skip right uh, past onboard charge and goes straight to the battery directly. Notice how thick these orange cable are compared to the thinner wire on the AC side. That's because DC fast charging push a lot more the current through directly into the battery. You can see the voltage number of this screen too, right. So this is the what allow AC charging to be much faster. And just like before, the power end up in the same place. The battery pack, so here at the bottom right, you can see here. So here the one sentence to take away from this whole slide, on the AC slide power conversion happen inside the vehicle and The onboard charge is the bottleneck for the speed, but it keeps the thing simple outside the car. On other hand, the DC side, power conversion happen outside the vehicle before it even reaches the car. That's what allow DC charging to move to much faster, more power, so much faster. Okay. Now that's the micro view, same grid, same battery, but two completely different journey from the power to take. Keep this one picture in your head because everything else you cover about charging build on exactly this difference. So let's move to the setup, okay, where we use the oscilloscope to understand different between AC and DC current and how their properties. Okay, okay, let's move to the setup then.
Alright, so I made a setup in my desk that allows us to visualize the voltage of the electric grid that is being delivered into my home. Via this probe that reduces the voltage by 500 times, I connect it to the socket outlet and I have a device here called an oscilloscope that is able to plot the voltage as it's measured. It uses the y-axis to show voltage and the x-axis to show time. So why is this alternated? It is alternated because you can see, whoops, you can see that it goes through zero. The voltage becomes positive, negative, positive, negative, and this is why it's alternated. And you can see that the frequency is 50 Hz, as it is everywhere in Europe. You can also see here that the voltage RMS is 479 millivolt, and if you multiply that by 500, you will get a number of 239, which is pretty close to the nominal voltage in Europe, which is 230 volts. So I hope this helps illustrating alternating current. It is naturally a sine wave as produced by the generators, and this is the system that is used to be transported and delivered in electric grids since the time of Nikola Tesla. So now I adjusted my system to be able to show you a system of direct current while measuring the voltage produced by this benchtop power supply. I can also regulate it, and so it's regulated to 12, and I can regulate it to less, and you can see that line going down in the oscilloscope there, which shows just the voltage that is being measured. It is a line because it's continuous in time, it doesn't change much, and it's not alternated because it does not go through zero. So it's a direct current that is being produced by this power supply. This power supply, what it does is it inputs alternated current from this socket outlet and it converts into DC and has a regulator that allows me to regulate more or less.